Right. Hey, everybody. So I actually wanted to follow up with our last video and sort of make explicit this observation that we were beginning to uncover specifically for the function x squared. As a reminder, we saw that when we took a set in the domain, so that was our set 1 to 2, we took the image of 1 to 2, and then we took the pre-image of that. What we got was actually the set 1 to 2 again, plus this additional set from -2 to -1, right? So the pre-image of the image of our original set contained our original set, but also possibly some additional things. It turns out that this was not an accident. This was a expected occurrence. This is something that will occur with any set or any function when we compose an image with a pre-image. And in fact, we have a similar statement that we can say when we compose a pre-image with an image, or whatever the opposite of the one I said before is. In other words, we have the following two statements, which I'm going to call a lemma. For any function f and any set a, I should clarify here that I do want a to be in the domain. Set a in the domain. We have that a itself will be a subset of the pre-image of the image of a. And similarly, for any function f and any set b in the codomain, we have that the image of the pre-image of b will be a subset of b. So notice, kind of interesting, how the order of these two sort of flips around. Here, A is a subset of the composition, while down here, the composition is a subset of B. I also want to say, when I talk about our set A, when we're talking about it being in the domain, what I really mean there is that I want my elements of little a to actually map somewhere under the function. So I want the function to apply to these elements, and that will be important in our proof. Okay, so here's our proof. We're just going to prove the first statement. The second statement will be similar. And the truth is, this proof is relatively straightforward as long as we can navigate what it means to be in the image, what it means to be in the pre-image, and just navigate some challenging notation, right? So we're going to, we want to show that our capital A is a subset of f inverse of f of a, so the pre-image of the image of a. To do that, we are going to take an arbitrary element of a and show that it is in f inverse of f of a, right? So let little a be an arbitrary element of big A, and I just want to, again, clarify that little a is in the domain. So since little a is in the domain of capital A, let me try that again. So A is in the domain, it is also in capital A, and our big and all goal is to show that A is in the pre-image of the image of A. Okay, now I'm gonna read the rest of this verbatim and then we'll piece together what it means. Since A is in set A, we know that f of little a is an element of f of big A. So f of little a is an element of the image of A. But since f of a is in the set f of big A, and since little a maps to f of a, we also know that little a is an element of the pre-image of f of a. Okay, so that's a little bit of a word salad. Let's figure out exactly what that means. And I think it is informative to change some of our language into something new, or to rename some sets. So since A is an element of big A, we know that f of A is an element of f of big A. Now I'm going to rename f of A. Let's call that B. So that is the element in the codomain that A maps to. F of A is equal to B. And I will also name f of little a, f of big A I'll rename f of big A, right? That's a set. That is the image of set A. Let's just name that big B, capital B. All right. So since since little b is in the set big B, and since A maps to B, okay, we know that A is an element of the pre-image of B. Let's think through that statement, right? So since little b is in the set big B, anything that maps to little b will be in the pre-image of big B. And in particular, since little a maps to little b, little a will be in the pre-image of big B. Great. The final thing that we have to do in this proof is we have to recognize that the pre-image of big B is the pre-image of f of capital A. And so what that means is A is an element of the pre-image of big B, aka the pre-image of the image of A, which is exactly what we were trying to show. So, hooray. All right, that's going to do it for me for this video. I will see you next time.